Hi folks, this is Nat, and this is going to be your video lesson on rounding numbers to specific places and also on estimating with rounding. The first thing that we're going to cover is this idea of what is rounding, which weirdly I feel like students come into 6th grade not actually understanding what rounding is. They know how to do it and what rules to follow, but not why. And so we're going to take a second to talk about what rounding actually is. And to do that, we're going to take this number, 27 and 36/100ths, to go through kind of what rounding looks like in different place values. When we round, all we're really doing is saying what number a number is most close to. The number is going to become a little less specific, but we're going to basically be saying, okay, this is close enough, and it's closer to this number or it's closer to that number. Let me show you what I mean. Let's say I want to round 27 and 36/100ths to the nearest whole value, the ones place. That's here. If we picture a number line, what we're really saying is that this number, rounded to the nearest whole value, is going to either land on 27 or 28. And because it has 36/100ths attached to it, or better yet, 3/10ths attached to it, if I was going to graph this on this number line, it would land somewhere around here. So when I round it, what I'm basically saying is that based on its location on the number line between the two holes that it's closest to, it is closer to this 27. So it's going to round to 27. On the other hand, if I'm talking about rounding to the nearest tenths place, let's say, I'm basically saying again, well, this is above 27 and 3/10ths, and it's below 27 and 4/10ths, but which one is it closer to? Because it has the 6/100ths attached to it, it's much closer. Well, it's going to land right here on our number line. And again, that makes it closer to being 27 and 4/10ths than it is to being 27 and 3/10ths. It's closer to that side. So when we're rounding, all we're really doing is saying what is it closest to, given the place we want to round to. And that's where the rules of rounding come from. Let's take the number 27 and 36/100ths again as an example. The rules of rounding tell us, first off, that we need to identify the place that we want to round to. And let's say as an example that this time we want to round to the tens place. First off, I need to identify where the tens place is. In this example, that's going to be this 2. So I'm rounding, let's say, to the tens place. The next thing that I do is I look to the number to the right of that place, the next place down. So if I'm going to round to the tens place, I'm not actually looking at the tens place, I'm looking at the ones place. I'm looking at this 7. Because the 7 is going to tell me whether this number is closer to just being a 20 or whether it's closer to being a 30. Recognizing that I'm either going to leave the tens place that I'd like to round to alone, leave it as a 20, or round it up because it's closer to being 30. And that 7 is going to tell me what is the case. So if the number to the right is a 0, 1, 2, 3, or 4, it's closer to being a 20 in this case, and you'd round down. Rounding down doesn't mean I reduce the 2 to 1, it just means I cut everything else off. I'm dropping the 7 and 36/100ths. If, on the other hand, that number to the right is a 5, 6, 7, 8, or 9, I'm going to round up. I'm going to change the 2 to a 3 and call it 30. So in this case, rounding to the tens place, it's going to be a 30, because the 7 tells me it's closer to 30 than it is to 20. Let's say I want to round 85 and 361 thousandths to the nearest hundredths. Well, I can follow these steps. The first thing I'm going to do is identify the place I want to round to. The hundredths place is going to be this 6. So I'm thinking, okay, I want to know whether that 6 stays the same or increases to 7. So I've identified the place to round to. Next, I'm going to check the place on the right. The place on the right is this 1 here. And I'm thinking, is this a round down or round up scenario? 0, 1, 2, 3, 4, well, it's a 1, so I'm going to be rounding it down. Again, that doesn't mean that I reduce the 6 to 5. I leave the 6 alone, and I just drop everything. So when it's rounded, it's going to end up looking like 85 and 36 hundredths. It just stays the same, dropping everything after the rounded place, because that's what rounding down is. Let's say I wanted to round that same number to the nearest tenths. Again, the first step is going to be to identify that place. That's the 3, that's the tenths place, and I'm looking at the place to the right of the tenths, and which in this case is the hundredths. And that 6, because it's 5, 6, 7, 8, or 9, is going to tell me to round up. That means, again, that it's closer to 85 and 4 tenths than it is to 85 and 3 tenths. I'm going to change that 3 to a 4, and I'm going to drop everything after my rounded place. So it would end up being 85 and 4 tenths. An important thing to recognize is you're never going to write anything after the place you've rounded to. Tenths was the place that I rounded to, so I didn't write anything after. Everything after the rounding place gets dropped. You shouldn't even include zeros. So one thing we can do if we're good at rounding is we can estimate by rounding. We can estimate addition and subtraction by rounding to the same place for each value and making our addition and subtraction a little bit easier. Normally this would be done with you just rounding to a place you could hold in your head. Estimation is normally meant to be something that you do mentally. You don't write things down generally when you estimate. That's the whole point of estimating, is you can do it quickly in your head. But for today we're going to really be focusing on the rounding part, so I'm going to give you some places to round to. So let's say, for example, I wanted to round 9 and 324 thousandths, or sorry, add 9 and 324 thousandths to 7 and 481 thousandths by estimating to the nearest tenth. Pretty easy. All I'm going to do is what I've been doing before. I'm going to round each of these numbers individually to its tenths place. So 9 is going to be rounded to the tenths place, 7 will be rounded to the tenths place, and again, for each of these, I'm looking at the number to the right. 2 is going to tell me to round that number down, whereas 8 is going to tell me to round this number up. So I'll rewrite the problem for the sake of being able to see it, and I'm going to say, okay, 9 and 3 tenths, because 2 tells me to just drop everything, don't do anything to the 3, plus 7 and 5 tenths, because the 8 tells me to increase my 4 to a 5. Everything else again gets dropped. Now I can add those up. And I'll say, okay, 3 tenths and 5 tenths is 8 tenths, and 9 and 7 ones are going to be 16. So my estimate would be 16 and 8 tenths. One thing that's important to note about estimating with addition and subtraction is that you always have to round both numbers, or all the numbers if there's more than 2, to the same place value. We never estimate addition and subtraction by rounding one number to one place and one number to another. So in this case you saw I rounded both to the tenths, not one to one thing and one to another. That is not the case when you estimate multiplication. When I estimate a problem like this with multiplication, I don't worry about rounding to the same place. I round each number individually to a place that I feel comfortable holding in my head. Some of us probably can do mental math with bigger numbers, and some of us like to have smaller numbers, and that's okay. So there's a handful of ways that we could approach this problem, 845 and 6 tenths times 9 and 34 hundredths. The easiest way is probably to round each number to its highest place value. So in the 845 and 6 tenths, that would be the hundredths place, and in the 9 and 34 hundredths, that would be the ones place. And again, in multiplication, it's okay to round differently for different numbers. Rounding my 845 to the hundreds place, I'm going to be looking at the tens place to determine whether to round up or down. In this case, 4 tells me to round down, so I'm not going to change the 8. I'm going to leave it alone. And because this is in the whole values, I'm going to drop all these numbers, 4, 5, and 6, but I'm going to need to replace the numbers up to the decimal with zeros so that I haven't moved my 8 out of the hundreds place. If I just wrote 8, it obviously wouldn't be 800 anymore, it'd be 8 ones. When I look at the 9 over here on the right, I'm going to be looking at the 3 in the tenths place. And 3, like the 4, tells me round down, so I'm going to leave the 9 alone. I'm not going to do anything to it, and I'm going to drop everything to the right. I don't need zeros this time because these are decimal values. 9 is still in the ones place, even if I don't write any zeros. So what I'm really doing is 800 times 9. 8 times 9 is 72 with 2 zeros. There's my multiplication estimate. Finally, the rules for estimating division are totally different than the rules for either addition and subtraction or multiplication. Let's say I'm trying to divide or estimate a division for 83 and 6/10 divided by 8 and 71/100. The first thing I'm going to do is follow my rounding rules for my dividend. Sorry, for my divisor. That's my second value. So I'm going to be looking at this second value and rounding it to a manageable place, typically the highest place. So 8 and 71/100, I'm going to be rounding to the ones place since that's the highest place. So again, like before, I'm going to be looking at the number to the right. 7 tells me to round up. So I'm going to change my 8 to a 9, and I will drop everything afterwards. This is the part that gets a little bit weird. I won't actually do any rounding for the rest of this problem. What I'll be looking for is a division fact that's close to 83 and 6/10 divided by 9 that works out easily and that I can do in my head. So when we think about 83, we need to think of a division fact that's close to 83 and divisible by 9, a number close to 83 and divisible by 9. In this case, 81 is very close to 83 and divisible by 9. That's what I'll use. 81 divided by 9 is 9, so that's my estimate for my division. The big thing to remember here is that when I round, I'm rounding my divisor, my second number. That's the one that's most important to round correctly because that's going to determine how close you get with your estimate to the actual real answer. If I'd rounded the other, it would have been, one, harder to find a division fact to match it, but more importantly, it would mean that my estimate would be most likely further off. So we round the divisor, not the dividend. And here are your practice problems for the lesson. Good luck.